is recorded it. Is the screen visible?
Yes, sir.
Yes, sir.
Okay, so let me tell you today that the remaining portion for matrices will be stopped here, because in the remaining portion, the another concept of determinant, that is the new term to you, determinant is required. So let me begin the definition for determinant today. So for determinant, you have to learn about a good concept regarding a square matrix. So already you know that what do you mean by square matrix? A matrix having equal numbers of rows and columns, isn't it? So a determinant is formed from a type of a square matrix. मतलब जब मैट्रिक्स का सभी रो और कॉलम सेम होगा, वहां से डिटर्मिनेंट का कॉन्सेप्ट आएगा. दैट मीन्स द डेफिनेशन ऑफ डिटर्मिनेंट will starts from a concept of a square matrix. ओके, एक डिटर्मिनेंट फॉर्म होने के लिए उसका सभी रो एंड कॉलम शुड बी सेम, इक्वल नंबर्स ऑफ रोज एंड मैट्रिसेस, sorry, equal numbers of rows and columns. So what is the definition? If all entries means if all the elements of a square matrix are kept in their respective places and the determinant of this array is taken, then the determinant so obtained is called the determinant of the given square matrix. Definition is very clear. For a determinant, sorry, for a determinant, what you have to see first thing, एक determinant के लिए the rows and columns in that particular determinant should be always same. Okay, so if A is a square matrix, then the determinant of capital A is denoted by, see, the symbol for determinant is the close bars and the matrix A, or simply you can write as det A. Det A means a determinant of A. It's simple. डिटर्मिनेंट में कोई भी ऐसा डिटर्मिनेंट नहीं होगा जिसमें रो एंड कॉलम सेम नहीं होगा. जैसे कि सपोज इफ यू कंसीडर ए व्हाट रो मैट्रिक्स, or if you simply consider a column matrix. So what is in row matrix? A row matrix contain only one row. It contains what, more than one column, isn't it? लेकिन डिटर्मिनेंट के लिए ऐसा हम लोग को मैट्रिक्स चाहिए जिसमें सभी रो और कॉलम सेम होगा, इक्वल नंबर्स ऑफ रोज एंड कॉलम्स. जैसे कि सपोज 3 रोज होगा, देन दैट विल कंटेन आल्सो 3 कॉलम्स. फाइन. सी, evaluation of determinant, that is the expansion. See, just made a copy for you. Just write two differences between, write down, just make a notebook. एक notebook में लिखो difference between a matrix and a determinant. Have you got my point? Hello? Am I audible?
Yes, sir. Yes, sir. Yes,
Okay,
sir.
just write
Yes,
down a
sir.
point on your notebook. It's an important point because regarding your exam purpose, what the difference between a matrix and a determinant. Okay, so number one difference, write down number one difference. A determinant will have, write down, a determinant will have equal numbers of rows and columns. A determinant will have equal numbers of rows and columns, but a matrix may or may not have equal numbers of rows and columns. Have you got my point? I just say one more time. A determinant will have equal numbers of rows and columns, but a matrix will may or may not have equal numbers of rows and columns. Okay, is it all right? I am again
Yes,
repeating the
sir.
Yes, sir.
difference. A determinant will have equal numbers of rows and columns, but a matrix will may or may not have equal numbers of rows and columns. मतलब मैट्रिक्स में equal numbers of rows and columns हो भी सकता है, नहीं हो भी सकता. For example, square matrix में equal numbers of rows and matrix है, and diagonal matrix also equal numbers of rows and columns. In case of identity matrix also, but in case of rows and in case of what row matrix and column matrix, the matrix will not have what equal numbers of rows and columns. But in a determinant, that determinant always contains equal numbers of rows and columns. That is the first difference. Okay, second, before going to write the second difference, just go to the PDF that is visible on your screen. See, evaluation of determinants. That means a determinant can be expanded always. Matrix में ये नहीं होता. A matrix cannot be expanded, isn't it? See, how can you evaluate or how can you expand a determinant? Second order determinant. See, here it is written as determinant symbol A, B, C, D. Now you see, the first row is AB, the second row is CD. Similarly, the first column is AC, second column is BD. That means in this determinant, the order is what? 2 by 2, no? 2 by 2. So in determinant, we can simply spoken as a second order determinant. Okay. Here, the order of the determinant is second order. 2 rows and 2 columns. Always remember, determinant contain equal numbers of rows and columns. Now, first row contain AB, second row contain CD, first column contain AC, and second column contain BD. How can you expand this determinant? The question is that. In the right hand side, it is written as equal. Sorry, kindly mute yourself. See, in the right hand side, it is expanded as AD minus BC. How can you expand this one? What is the rule for expansion? Just see here. For expansion, kindly mute yourself. Kindly mute yourself. Mamuni Begum, please mute yourself. Mamuni Begum. Bhatnakol Dasisa, kindly mute your microphone. Okay. See, in the right hand side, how it is AD minus BC. Question is that is how can you expand a second order determinant? This A, B, C, D are nothing but the elements. पहला रो का element क्या है? A and B. The elements of the second row are C and D. Okay, for expansion, what is the process? You have to just here in a very positive way. See, how can you expand? For expansion, you have to multiply. Second order determinant का expansion अच्छी तरह सुन लो, because that will help you for doing further calculations in matrices. Okay, so for second order expansion of second order determinant, you have to multiply the elements of the upper left corner to the lower right corner. That is A into D. It is AD. Then for expansion a formula minus is given as minus, ये formula का minus है, ये automatically आएगा. Then again you have to multiply the upper right corner element to the lower left corner element, that is B into C. Getting my point? Second order determinant का expansion कैसा होगा? For that you have to begin with the upper left corner element, that is multiply the upper left corner element to the lower right corner element minus lower left corner element to the upper right corner element multiplication. Okay, that is simply as AD minus BC. Fine. Understood? Have you got the result AD minus BC? Any doubt? How can you
No,
expand
No,
the
sir.
sir. No,
second
sir.
order determinant? Hello? Hello? Any doubt regarding the
Yes,
expansion
sir.
of the determinant?
No, sir.
No, sir.
Wait for a few seconds. Okay, hello? Okay, now see, this expansion is very much simple. That is the expansion for second order determinant is very much simple. Now the problem will arises in case of the expanse of a third order determinant. It is very important, so listen very carefully. Okay, so now the third order determinant, this is the third order determinant, a1 b1 c1 a2 b2 c2 a3 b3 c3. Okay, uh, clearly here you can see 3 rows and 3 columns are there. That's why the order of this determinant is 3 by 3 in matrix form, but in determinant you can simply say as a third order determinant. Now listen carefully, what is the way for expanding? Okay, see here, for the expansion of the third order determinant, you will begin with the element of the upper left corner. I am again saying, say here a1. a1 is written, okay, into a1 के साथ एक determinant multiply किया है, and how can you got the determinant? See, if you choose the element a1, you have to neglect the column and row that a1 exists. So if you neglect the column and row that a1 exists, that is a1 a2 a3, the column will be neglected, and a1 b1 c1, the row will be neglected. So what is the remainder determinant? Remain determinant is what? b2 c2 b3 c2, that is the one. Okay, the first determinant is like that, b2 c2 b3 c3. How can you got? Again I am saying, you have to neglect the column and row that a1 exists. उसके बाद जो डिटर्मिनेंट मिलेगा वही यहाँ में लिखना है, दैट इज b2 c2 b3 c3. Understood? Next, since before a1 no symbol is there, that is positive symbol is there, so symmetric order will come, the minus will come over here, that is minus. Then you choose the next element b1. Now when you choose b1 as the next element, neglect the column and row that b1 exists. So what is the determinant left? See, b1 का जो column है, b1 b2 b3 will be what neglected, and a1 b1 c1 will be neglected. So what will left? a2 c2 and a3 c3. See here, a2 c2 a3 c3. Okay, then again after minus symbol plus will come over here. Then again choose the next last element, that is c1. After choosing c1, you have to neglect the column and row that c1 exists. So what is the determinant left? See, cancelling the column, that is c1 c2 c3 will be neglected, and a1 b1 c1 is also neglected because this is the row that c1 exists. So what is the determinant left? A2, B2, A3, B3. See, A2, B2, A3, B3. Okay, it's very simple. So first line for expanding the third order determinant, is it clear? Is it clear the way for expanding the third order determinant? That is the first line. Or any
Yes, sir.
doubt?
Yes, sir.
No. Okay. Then see, after getting the first line, you will easily got the second line. थर्ड लाइन इज नॉट वेरी मच इंपॉर्टेंट बिकॉज थर्ड लाइन जस्ट मल्टीप्लाई कर दिया है, बस कोई नहीं है. ठीक है. नाउ हाउ कैन यू गो द सेकेंड लाइन? अगेन फॉर गेटिंग द सेकेंड लाइन you have to expand the second order determinant that is already formed in the first line. See how? See, a1 is written in the second line, a1 into bracketed will start. Now again just recall the expansion of second order determinant. Multiply the upper left corner element to the lower right corner element, that is b2c3, b2c3 minus formula, then b3c2, b3c2. Again minus b1 is written, a2c3 minus a3c2 plus c1 a2b3 minus a3b2. Very simple. So the first two lines are compulsory. The third line, how can you got? Just multiplying a1 with every element, b1 is every element, c1 is every element. Third line is the necessary nahi hai. The main important thing is that the expansion for the first line and the second line. It is very much important regarding the matrix concept. Okay, understood? So in this way, we can expand a second order determinant and the third order determinant. Okay. So next, what? Okay. Now see, some symbols are there. Wait. Okay. It's not necessary actually. Properties also not necessary. हम लोग को ये सब नहीं चाहिए, properties वगैरह. Okay, this thing is we will need. Hello, am I audible?
Yes,
Yes,
sir.
sir.
Okay, now
Yes, sir.
in the concept of a determinant, how can you find the area of a triangle? Okay, from this article, question will come in your examination. Remember, okay, area of a triangle के लिए निकालने के लिए you have to use the concept of coordinate geometry. It's very simple. You already got in class 10. How can you got the area of a triangle? By using coordinate geometry concept, isn't it? Now here, by with the concept of determinant, how can you got the area of a triangle? See, for area of a triangle, you already know the three vertices will be required. So if the vertices of a triangle are x1 comma y1, x2 comma y2, and x3 comma y3, then the area of the triangle is, see, area equal to the symbol for triangle, that means what? The area equal to half into determinant of d. Okay, now what is determinant of d? Where d is determinant, this one, x1 y1 1, x2 y2 1, x3 y3 1. So this x1 x2 x3 y1 y2 y3, already you have the values for those values. यहाँ में से निकालना है, that is x1 y1 का वैल्यू तुम लोग को दिया जाएगा, x2 y2 का वैल्यू दिया जाएगा, and the values for x3 y3 is also given. Just you have to plot in the determinant and just expand that, you will got the area of the triangle. Okay, Now from here, a small note is given. What is that note? If capital D equal to 0, that means if the area is sorry, the determinant is 0. Suppose यहाँ में तुम लोग का you will have the values for x1 y1 x2 y2 x3 y3, and after plotting all those values in the determinant, and if you are going to expand the determinant, that is a 3 by 3 order determinant, if you expand that and finally suppose you are getting that the value of the determinant is suppose 0, then what conclusion you can make? That determinant 0 होने से क्या होगा? You have to put it over here, that is area should be 0. And what will have if the area is 0? एक ट्राइंगल का एरिया 0 होने से क्या मतलब what can you make the conclusion? If the area of a triangle is 0, then the conclusion is made as what? The
3 points are collinear.
says yes, the points are lie in a collinear way. That is the note. तुम लोगों को सपोज एक क्वेश्चन दिया जाएगा, सपोज द एरिया ऑफ अ ट्राइंगल इज 0, देन व्हाट कंक्लूजन यू आर मेट, or simply a condition should be you are asked to be proved. So for that you just expand the determinant and just plotting by determinant equal to 0, you will get the required condition. Okay, so this thing is required. And one more important concept, that is yeah, this one. How many properties are given here? Lots of properties, but all the properties are not required. See, the first property, what is the first property of determinant? If a row or column is a zero vector. What do you mean by that? If, that is, all elements of a row or column are 0, then the value of D equal to 0. What do you mean by that actually? Suppose when you are going to expand a determinant, okay, and you are finding that in a particular row or in a particular column, if all the elements are 0 for that row or column, then without expanding the determinant, you can directly say that the value of the determinant is 0. That is one property. Understood? I mean to say, if all the elements of a row or column is 0, then without expanding the determinant by the expansion formulas, you can directly say that the value of the determinant is 0. That is the first property. Fine. Okay, the next property is what? Number 2 property. If two rows or columns are identical, then the value of the determinant is also 0. Again, this is one of the most important property of a determinant. What this property tells you, that अगर किसी भी डिटर्मिनेंट का कोई भी दो रो और कोई भी दो कॉलम, इफ एनी टू रोज और एनी टू कॉलम्स, और ओके, और अगर कोई भी दो रो और कोई भी दो कॉलम आइडेंटिकल, मतलब वर्ड सेम होना होगा, ठीक है. इफ एनी टू रोज एंड एनी टू कॉलम्स सपोज आर सेम और इक्वल, then here also, without expanding the determinant, you can directly write the value of the determinant is 0. So these are the two properties that you can directly say that when a value of the determinant is 0. एक तो ये है कि एक रो और कॉलम का सभी एलिमेंट 0 होने से determinant will be 0, and if two rows or two columns are identical, then you can also say that the value of the determinant is 0. Okay. The third property, see, if any two rows or columns are interchanged, then D becomes minus D. What do you mean by that? What do you mean by that? Suppose in a particular determinant, if you are going to interchange any two rows or any two columns, then जो determinant का result आएगा तुम लोग का, suppose the value of the determinant after expanding is 2, but if you change the two rows or columns, suppose if you are changing the two rows or columns, the result should be minus 2 in place of 2. Why? Because already you are changing or interchange any two rows or columns. Okay, that is the third one. Fourth one is not necessary. Fifth one you can say. Just see the fifth one. Okay, just see the fifth one. What you have seen in the left hand side determinant. In the left hand side determinant, the elements are given, okay, and in the first row a constant k is multiplied with every element of that row, isn't it? See here, a constant is multiplied to a1, b1 and c1. So अगर एक कोई भी एक कांस्टेंट किसी एक पर्टिकुलर रो के सभी एलिमेंट के साथ मल्टीप्लाई होता है, सो उसका रिजल्ट क्या होगा? The value of the determinant is what? The particular constant is coming outside. Here you can see the right hand side. The particular constant is coming outside as k, and from that particular row the k will be eliminated, isn't it? See the right hand side, no k in the first row, others are same, other rows are same. What you have to do, if a particular row is multiplied with the same constant, then as a result the same constant is coming outside, and in the from the particular row that particular constant should be eliminated. That is the simple one. Same case we'll have in case of column also. Suppose in that case, suppose ka1, ka2, ka3 is here. Same constant will come outside in the right hand side, then k will be eliminated from the first column then. Okay, that will holds for each row and each column. Column के भी साथ भी हो सकता है, and row also. Okay, then the sixth one, sixth property. Okay, sixth one is again important. See, in the sixth property, second and third row are similar. First row, a1 d plus d1, b1 plus e1, c1 plus f1. That is addition symbol is given in the first row. Then you can say as right hand side you can see the plus is separated. A1, b1, c1 is written in one determinant. Then d1, e1, f1 is written in the other determinant. Other two rows are same. So other properties are not required. These four properties are important. Okay, but see, we have a lack of time. The minor and cofactor, this is the most important one, because already I told you in the what in the next portion of matrices, the concept of minor and cofactor are very much required. Without these two, you will not be able to find some, suppose other relative particles like inverse, adjoint of a matrices. So next class we will discuss about the concept of minors and cofactors. Understood? It's very much important. Again, I'm saying. So uh, let me just stop sharing the portion.